Hi everybody and welcome. Today's video is going to continue our discussion about similar triangles, and to be specific we're going to look at some of the theorems behind specific similar triangles, and those theorems are going to help us with writing down some proofs for these similar triangles. So just to start off, a quick refresher: a similar triangle is our vocab word, and a similar triangle is just a triangle with the same shape and angles, as well as proportional side lengths. So this is something, again, that we covered quite a bit in our last class period. So if we have something like a small equilateral triangle, if we have a large equilateral triangle, what we're going to see is obviously the sides are not exactly the same length, but all of the angles are the same, and the sides proportionally get bigger or smaller. So let's say, for instance, if we had a side of 2 here, and this is a side of 6, if we're getting our scale factor, we would just take our big side divided by our small side, and that would solve for our scale factor. So in this case, our large triangle is 6, our small triangle is 2, so you get a scale factor of 3. And all that scale factor is saying is, well, the triangles, they are similar, and they have the same angles. The small triangle, if we make it 3 times bigger, that's what a scale factor of 3 means, then we're going to end up with the large triangle that we see. So we have a couple of theorems that allow us to prove that triangles are similar, other than just passing the eye test or checking for every single angle or other things along those lines. So the first one is our angle-angle similarity theorem. So this is not for congruence. We're not saying the triangles are the same in every way. We're just saying that they are proportionally similar. So this is if we have two angles of one triangle are congruent, we use the congruent symbol there, to two angles of another triangle, then we know for sure that these two triangles are similar. So in our example below, if we had something like this, P and T are congruent and Q and S are also congruent, that's enough. We don't need the third angle, because basically we know the third angle would have to be the same because triangles add up to 180, but if we can prove that two angles are the same, that's all we need. And if we can say that those two angles are the same, then we know for certain that they are in fact similar triangles. So writing our similarity statement, P to Q to R, we use our similar symbol, and then we can go from T to S to U. So the second theorem that we can use here is our side-side-side similarity. So this one is checking if the measures of corresponding sides of two triangles are not the same this time, but just proportional. So if they are in proportion, then the triangles are similar. Now in this case, we have to ensure that all three sides are proportional. So 2 is not good enough. All three of them have to be proportional. So for example, if we had something like for A, B, and C, 1, 2, and 3 as our side lengths, what we're going to have to see here is that when we multiply A times something or B times something or C times something, they all have to be multiplied by the same thing. So in this case, if this triangle has a scale factor of 4, we'd have to multiply all of these side lengths by 4. So 1 times 4 is 4, 2 times 4 is 8, and then 3 times 4 gets us 12. So what this does is our sides that match should be in a direct proportion to each other. And the way that we were testing this last class period is when we put these two triangles together. So if we had red over green, and then red over green, so seeing that the 1 goes here, the 2 goes here, 4, and then 8 like so. So if we do that, when we do cross multiplication, we should get the same answer. So 8 times 1 getting us 8, 2 times 4 also getting us 8. So that is one way that we can prove that sides are proportional. So we would have to do it for all three of our sides in this case. So we lined it up for red and green. Just to double check, we also want to line this up for yellow and red as well. So again, cross multiplying 1 times 12 is equal to 3 times 4, or 12 is equal to 12. So we've proved proportional for all three sides are matches for proportionality. So if and only if we're able to do that, we can make our similarity statement of P to Q to R, and then of triangle T to S to U. So our last similarity statement for today is side angle side similarity, and this is just if the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle. So two sides match two sides, and the included angle are congruent, then the triangles are similar. So what this is telling us specifically is that, let's say we have just two side lengths that match, so A and AX and B and BX. The second piece is that the included angle must also be a proportional match. So in this situation specifically, we need to have the included angle, the angle that is in between. So if we can do that from a side to an angle to a side, then we're able to prove that these are in fact similar. So again, we'd want to set up our cross multiplication to prove that they are in fact the same. So whatever these lengths are, so like A over B, and then AX over BX. So we can actually do it with variables too, it'll still work. So A times BX is the same thing as AX times B. And what we'll see here is that each side has an A, each side has a B, each side has an X. So these are actually proportional. And then we can see that our two angles in the center are matches for each other, so Q and S. So one more time, by a different method from a side to an angle to a side, triangle PQR is in fact similar to triangle TSU. So now what we can work through are some of the examples that we're going to see as we do some solving here. So for our first one, if we have FG equal to EG, so FG is equal to EG, so these two sides are the same. And if we know that BE is 15, so from B all the way down to E, that is 15 is that length. And it's going to be kind of hard to draw in sometimes. And from A to E is 9. And they tell us additionally that DF, so I'll draw this separate, is 12, and CF is 20. So determine which triangles in the figure are similar. So in this situation, there's a whole lot of vocab that we're going to be running into. So the first thing that we actually want to do is take a real narrow focus on our triangle in the center here. So if we have this side length and this side length similar, remember our isosceles triangle theorem tells us that this angle right here is the same thing as this angle right here. So that angle F and that angle E, both of those on the inside of that triangle. So if we clean all of this up, we can see that basically that means that our matches there, F is the same as E. So that tells us some additional information. A second piece of advice when you see something like this, especially the more confusing that it gets, is I would recommend separating this out. So we're just going to take our first triangle here with its little congruent angle, so A, B, E. We're going to move it off to the side, and we're also going to move our other triangle off to the side here. So this is F, C, D. When we do this, we can go back and we can relabel some of our side lengths. So we had 15 here, we had 9 here, we had 12 here, and we had 20 right here. And what we can notice is if we kind of match these up, it almost looks like if we rotate this around, that this triangle might actually be a better fit. So if we were to redraw this with F on the right side, just kind of do that 180. So moving D over here, F over here, and C over here, that angle E is a match for angle F, and that we should be able to match up our side lengths as well. So angle 9 on the bottom, or sorry, side length 9 and side length 12, and then additionally side length 15 with side length 20. So basically just flipping this around by redrawing it, it kind of helps us to see that the triangle kind of mirror reflected on itself. Even if you don't do that, you should still be able to see that our sides are matching to each other, just as our angles match to each other as well. So it doesn't matter. So if you want to ignore the fact that we flipped that one around, that's totally fine as well. And now what we have to do is we've proven an angle is the same. We just have to look for similarity for proportionality. So we have yellow over blue, we have yellow over blue, so it's time to do some cross multiplication and see if this one actually does work out. So in this case, 9 times 20 gets us 180. And then if we also do 12 times 15, so I want to punch that into the calculator. So 12, 15, those also get 180. So because of this, we proved that we have an angle that is the same, and we've also proved that our sides are similar. So we have our side angle side similarity is our reasoning. And then if we look at our figures, we want to match these up. We know that angle E and angle F are the same. So if we do triangle E is similar to triangle start with F, and then we can go to the top, so to B, from F to C, and then our only leftover one is A, and our leftover one is D. So remember, be careful, you do need to match those orders, so green angle first, top of the triangle second, and then the leftover one third. So the additional examples that we're given here are going to bring us through some of these similarity theorems as well. And what we're going to have to do is determine, are we in a similar situation with seeing some things that are in fact similar? Can we use some of those theorems to prove and to solve them? Or are we in a situation where we're stuck and we don't have those similarities? So you're going to see some of these pop up on our guided questions later. But for right now, I'm going to have us work through example number 2 and see if you can go through and get some solutions for what we see here. All right, so first thing, they tell us that RS and TU, so this line here and this line here are parallel lines. So remember, when we have transversals that go through parallel lines, we actually know quite a bit about the angles that go through them. So if we just focus on these, we know that we have some alternate interior angles here. So these should be similar. We have some vertical angles here. So these should be similar. And we know if we draw an additional transversal going through our parallel lines, that we have another pair of alternate interior angles. So actually, just by giving us the information that we have parallel lines, that's enough for us to concretely prove that all 3 angles in the triangles are in fact going to be equal to each other. So because of that, we can just do a quick match up of which angle equals which angle. That way we know when we're working through these, which ones are proportional to which ones. Second, because we know of this proportionality, we can take our side length, so our green to red, and then we can take our red to blue, and we can set them in a proportion to each other. And when we cross multiply, we know because of the angle-angle similarity that they do have to be exactly proportional. So cross multiplication should work. So 10 times x plus 3 should equal 4 times 2x plus 10. So distribute for both of these. And when we move some of our terms around, so subtract on both sides. Subtract on both sides again. And then divide and divide, we'll end up with an answer of x equals 5. So in this case, x equals 5 helps us out. They want RQ and QT. So RQ is x plus 3. So we know that RQ is equal to x, which we solve for, is 5. And then we know that QT is 2x plus 10. So x, again, we know is 5. So we're just plugging in for x here. So 2 times 5 gets us 10. So 10 plus 10 gets us an answer of 20 for QT. And then again, RQ we already solved for there. So those are the 2 solutions that we're looking for in this question. And again, using triangle similarity theorems, we're able to use the angle-angle similarity. We're able to know that our sides are proportional, and knowing all of those things and putting them together lets us do some solving and get some answers. So as always, thanks for watching. If you got questions, definitely let us know.